Have you ever had a situation like this where you have a quantity to like a third power or a fourth power where you need to multiply it out? X plus 2 cubed really means that you're going to do x plus 2 times x plus 2 times x plus 2. And in reality, one way you could tackle this problem is it's a big massive foiling problem. You could do this times this, this times this, this times this, this times this, and then times it all by this thing afterwards, and you'll get the right answer. But it leaves you a lot of room to make small mathematical errors. And what if I had said, oh no, I didn't mean third power, I mean sixth power. So instead I want to multiply this 6 times. I'd have to add an x plus 2, another x plus 2, and another x plus 2, and I don't even have room for it. So we have a strategy. We have something called Pascal's Triangle, and this is kind of a cool thing. This guy, Pascal, invented or found a pattern that turns out can help us with these large distributive problems. And his pattern, his triangle, looks like this. It starts with the number 1 and goes 1, 1. After that, it goes 1, 2, 1. Then it goes 1, 3, 3, 1. And then 1, 4, 6, 4, 1. And it keeps going from here. Each row, as you drop down, gets larger and larger. And can you see the pattern? Do you see what's going on in here? Think about it. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 1 is 3. 3 plus 3 is 6. Do you see these connections? So if I wanted to go down another row, 4 plus 6 is 10. Or 6 plus 4 is 10. Or 4 plus 1 is 5. And same thing on this other side. 4 plus 1 is 5. And every time we go out a row, we add 1s to the end. So Pascal's triangle, it gets larger and larger and larger past here. It's kind of this never-ending triangle. You can just keep going, make it bigger and bigger. And it's helpful because it helps us multiply out things to large powers. So I'm going to show you how this works. If I have a plus b to the third power, on Pascal's triangle, remember the triangle looks like this. 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Each row of the triangle refers to a power. So when I'm talking about something to the third power up here, it refers to this row. This is your third power row. The row above it, this row, is your second power row. This is your first power row. And this top one is your 0 power row. And so if I keep going down, here's your fourth power row. And I could continue to the 5th power, and the 6th power, and the 7th power if I kept making Pascal's triangle get bigger and bigger. So what we're going to do is we are going to use this third power row right here. And we are going to find out what a plus b to the third power is by simply using the 1, 3, 3, 1. And here is how it works. It's really smooth. You start with the a, and you break it down. You go a to the third, because it's a third power up here. And then you spread out and go a to the second, a to the first. And then technically you do an a to the 0. So you have a to the 3, a to the 2, a to the 1, a to the 0. Then you kind of go backwards with the b's. Since you have b, we're going to go b to the third, b to the second, b to the first, b to the 0. And then this 1, 3, 3, 1 from the triangle goes in front. 1, 3, 3, 1. Those are the coefficients. And all we have to do is add these terms together, and we have got our thing all distributed out. So it's kind of messy. I know it looks complicated, but if you clean up each of these terms, think about this first term here. 1 times a cubed times b to the 0, that's really a cubed. Plus this next term here is 3a squared b to the first power. So I'm just going to write plus 3a squared b. plus this next one here is 3a to the first, b to the second. That'd be 3ab squared. Plus this last term on the end here, 1a to the 0, 1a to the 0, b to the third is just 1 times b to the third is b to the third. These 0 powers, you really can kind of disregard them. They're ones. So here is my answer. Here is my factored out answer. This may look quite complicated, right, like in this format, but to be honest, it makes things easier, and I'll show you how this works in a real situation here. Let's say you needed to do x plus 3 to the third power. So you're going to have to do x plus 3 times x plus 3 times x plus 3, which is one big foiling mess. So instead, I'm going to use Pascal's triangle, and I'm going to start with the x, and I'm going to break it down into x to the third, x to the second, x to the first. Actually, I'm going to spread this out better. X to the first, and x to the 0. And then I'm going to go the other direction with the 3 that's up here. I'm going to go 3 to the third, 3 to the second, 3 to the first, 3 to the 0. And then my coefficients are going to be from Pascal's triangle. 1, 3, 3, 1. And we're going to add these terms together, add them up, add them up, add them up. And then we're just going to clean it up just a little bit because each one of these is messy. So this first term here, 1 times x to the third times 3 to the 0 is really just x to the third. Let's ignore the 0 power. Plus the next term here that we have is 3x squared times another 3. 3 times 3 is 9, so we have a 9x squared. So 9x squared. Plus this next term here is 3 times x to the first times 3 squared. 3 squared is 9. 9 times 3 is 27x. Plus this last term here is x to the 0 times 3 to the third. Well, x to the 0, let's forget about that. 3 times 3 times 3 is 27. So we have an answer of x cubed plus 9x squared plus 27x plus 27, all multiplied out. Some people think the Pascal's triangle is really complicated, but if you can get the pattern down, it's actually much faster than doing it what I would call the old school way of just being like, let's FOIL everything and multiply all these pieces out. Even though that totally works, the room to make a little error is, pretty big. So use Pascal's triangle, and it's just quick. You can get really fast at this. Especially, imagine you have something like 2 plus x to the 5th power. Who wants to multiply 2 plus x times 2 plus x times 2 plus x, 5 times? That's ridiculous. That's some serious amount of foiling. So 1, 2, I'm going to squeeze these in here. 2 plus x, 2 plus x. I don't want to do that. That's kind of crazy. So Pascal's triangle is going to make that easier. Just when you go to break it all down, now you got to go start with the 2 here and break it down. So it's 2 to the 5th. We're going to have to write it all out. 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, 2 to the 0. So it's going to be huge. And then you're going to go backwards with your x's. So now we're going to go x to the 5th, x to the 4th, x to the 3rd. Kind of hard to write on the iPad here. X to the 2nd, x to the 1st, x to the 0. And the coefficients come from that triangle. So can we backtrack a couple pages here and go back and look at that triangle when we were working on the rows? Remember, this was right here we had the 3rd row. Here's the 4th power. We're talking about doing something to the 5th power. So if I was to go one more row down, it would be a 1, 5, 10, 10, 5, and 1. 1, 5, 10, 10, 5, and 1. Those are the coefficients we're going to be using. So 1, 5, 10, 10, 5, and 1. Let's go do those. We're going to put them on here. 1, 5, 10, 10, 5, and 1. messy. And we're going to add these up, add all these terms up, clean it up, do some simple math, and have our answer. And really, this is still faster than being like, first times this, times this, times this, times this, then times this, times this, times this. You know what I mean? The giant FOIL process, it would be kind of disastrous with 5 different terms. So cleaning all this up, we have 2 to the 5th power times x to the 0. So really, I mean, we just got to know what 2 to the 5th is. So 2 to the 5th power is going to be, isn't that 32? 2 to the 5th? Yeah, I think it's 32. So 32, x to the 0 I'm not going to worry about, plus 2 to the 4th times 5. So 2 to the 4th is 16, times 5 is going to be 80. So we're going to have 80x to the 1st, so 80x. Plus 10 times 2 to the 3rd. So since 2 to the 3rd is 8, 8 times 10 is 80, and it's x squared. Plus 10 times 2 squared. 2 squared is 4, 4 times 10 is 40, x to the 3rd power. Plus 5 times 2 is 10, x to the 4th. And then our last term down here, 2 to the 0, let's not worry about that. We just have plus x to the 5th. And there is my answer. It's long, I know it's big and messy, but it's still faster than foiling all 5 of these terms up here out. So pick and choose your method, but I really like Pascal's Triangle. It's kind of neat. It's got this cool little pattern. You could change the power to anything you want up here and use this strategy, which is really kind of cool.